Let's see how to use Cramer's rule to solve a system. In this case, we're asked to solve for z only. That's okay. And we want to show our work. Okay, Cramer's rule states that z equals the determinant d sub 0, z, divided by the determinant d. What these determinants are, and let's just write it, d is the determinant. You can either write det and then the matrix, and this is the matrix of the coefficients, 5, 4, -1, 1, -3, 4, etc. Or you can write these as absolute value bars. This is the only time you write absolute value bars around a matrix, and that is when you're referring to the determinant of said matrix. Okay, there are several approaches. There's the expansion by cofactors that is primarily covered in the book. There's also a cross-multiply type of technique. The expansion by cofactors, I kind of covered up the 5. Let's do that one since it's covered in the book. It would be the first one. 5 is double crossed out. And when I double cross those out, notice I have a little 2 by 2 area left over, the determinant of that 2 by 2. I still need to find. The next one, it's the opposite of this, so -4. And if I cross out the negative of the 4, I can see that 1, 4, 2, 1 left over. And finally, the same that sign, so -1 and the determinant. And if I cross out that -1, I can see the 1, -3, 2, 1 left over. Okay. Now, to finish this, we need to do the down product, -3, minus the up product, 4, is -7. And then -4 times, similarly, the down product, 1, minus the up product, 8, -7. And finally, the down product, 1, minus the up product, -6. Notice it's always down minus up. Sometimes the up product is negative, in which case it ends up being a plus, but you always want to set it up as a minus. Subtraction. All right, so that is 5 times -7 minus 4 times -7 plus, -1 times 7, -14. So that's D, a little bit smaller. There we go. So D is that determinant. We found the denominator. What dz is it's the exact same determinant that we just did, but the z column is replaced with the numbers in the equation. I'll put them in a different color just so that you can see that those numbers are popping into the z column because we're looking for dz. Those would replace the y column for dy, replace the x column for dx, etc. Okay, let me demonstrate the other approach for the 3 by 3 determinants, because there were quite a few mistakes with the first approach. What you do is you copy down the first 2 columns, and now the basic principle of the 2 by 2 determinant, down minus up, is repeated here, but now there are 3 down products. and there are 3 up products. So it's down minus up still. And I'm going to use the calculator to make sure I get this right. So the 5 times negative 3 times 22 is the first down product, negative 330. 4 times 32 times 2 is the second down product, plus 256. And the third down product is the 28 times 1 is just 28. Okay, subtract the up products. We have 2 times negative 3 times 28. Oh, sorry. Try that again. About made a mistake. There we go. Negative 168. The next one is plus 160. That would be the 1 times 32 times 5. And 22 times 1 times 4. Again, we're just doing up products. That would be 88. So we have negative 33. Here, let's just put a parenthesis around it. The first parenthesis is not necessary, but it's safe to use. Minus the second parenthesis is critical, because that negative has to either distribute to all 3 numbers, or you have to work the 3 numbers out first and then distribute. Final answer, negative 126. So these are the 2 different approaches to doing a 3 by 3 determinant. I don't really care which one you use, as long as you're good at that approach. This 3 by 3, the down products minus the up products, only worked for 3 by 3s, whereas the expansion by cofactors works for 4 by 4s and 5 by 5s and on. It's a more general approach, but on the final you'll get nothing larger than a 3 by 3, so I like this method. I think it's a little more consistent as far as getting a good overall average on a question like this. So we worked out dz, that goes in the numerator. And the last thing to do is just to simplify negative 126 divided by negative 14, and we get z equals 9. So this is Cramer's rule. The dz you work out, the d you work out. I always work out d first, because if d equals 0, then Cramer's rule does not apply, and you could just say does not apply. Okay, I hope this helps.